And hello everybody! Hopefully we have audio this time. I'm doing something a little bit different this time because I checked back on the stream from last time and the audio was terrible. It was really echoey. I've got a lapel mic which is running through into my computer. Audio, cool, it's working. And I think the quality of the audio that will come off this is much better than the really echoey audio that was coming out of the built-in microphones. So hopefully we're in better shape today. Welcome everybody. So today, firstly, how is everybody doing? Is life kind of settling down to a normal, regular thing? Hey, Sion's here. Hey, Unexpected Maker. Okay, so alrighty, I've got a couple of ideas for today. One is, John says sounds so much better. Cool. Hey Guru, good to have you here. Even though it's probably pretty late where you are right now, I think, although not too bad. Okay, so I've got a couple of ideas about things we can talk about today. One is presence and occupancy detection, because that's come up a little bit on the Discord and it was mentioned last week. And also last week we were talking about power monitoring, and I was telling the story about the school that I didn't name, and the issue of leakage of information, like inferred information, when you have a small amount of data coming out of a system and you can figure out other things from it. So I did about 3 seconds of homework before this live stream, and I've gone out and grabbed hardware that I built, must be 11 or 12 years ago, which is what we used for that project. So I can show you that and show you a couple of little things about ways to do current sensing. And what else? Oh yeah, and I've got some Eagle projects I can show you, because I can follow on from what we were doing last time, last year, whenever it was. So, Incognito said I have a US, so ultrasonic distance sensor on top of my monitor, so my computer knows when I'm sitting in front of it. Very handy uses. That's cool. Alright, I'm going to show you some stuff for energy monitoring. I'm not an expert in this field. I've done a little bit of it, as you can see, but there are people that know far more about this than me. So that story I was telling you last week about the school and wanting a source of data that we could use for doing our software development, what I ended up putting together at the time are these little boxes, which are super crude, but they didn't cost all that much to put together, and it got us some useful data. And this is one of the devices that we had installed in the houses of my staff at my software company, and it was one of these that was recording the data that allowed us to see when my UI designer's wife got home, turned on the passage light, started the kettle, and did all of that stuff. So what is in here is quite simple, really. There is a little stack of boards in there. It's a bit hard to see, but there is an Arduino down the bottom. I think it was a Demilla Nerve. Then in the middle is a Wi-Fi shield, and then on top of that is a prototyping shield, which is just used for some connections as a breakout essentially. And you can see there's a chip on it right there. That's a watchdog timer. So that's a 555, and if the device fails to pat the watchdog, I don't remember what the timeout was on this, it was probably like 2 minutes or 5 minutes or something, then it would pulse the reset pin and force the device to reboot, and that allowed it to recover from situations like power outages and problems with Wi-Fi, because this was using Wi-Fi to connect to the house that we installed it in, and then it so it could recover. And the thing is that these were installed in people's houses around eastern suburbs of Melbourne, but one of these actually went into a shopping centre in Brisbane. I'll tell you about that one in a little bit, because that's kind of a cool story. And what that connects to, what we were using at the time, are these things. So these are current clamps, and essentially it's half a transformer. And if I push this open, you can see there is a metal contact in the end there. And so what happens is that when this is closed, there is a loop around here. So you get, imagine that this is your active lead, and you want to see how much current is going through that lead. What you do is clip this over the top, and then because of the, is it the right-hand law? I can't remember, right-hand law, left-hand law. You take your hand with your thumb sticking up and you curl your fingers. The thumb is the direction of flow, and the direction of the fingers is the magnetic field that goes around the flow of power. That field, if I put this back through here, is then aligned with this, and it induces a current, well, it induces a voltage in this, and then you can measure the voltage here. So the voltage that you get out of this is proportional to the current flowing through the wire, which then varies the strength of the magnetic field. So what you can do, left-hand law for current, right-hand for motors. Thanks, Toby. I can never remember which one is which. I've got to look it up. So what happened with this is that we would just plug up to 3 of these current clamps into the box, and then that goes into analog inputs on the Arduino, and then we would read the voltage. So the actual scale that comes out of this is selectable. It can be either 10 millivolts per amp or 1 millivolt per amp. So if you've got a 240 volt lead going through here, and you are passing 1 amp through it, so it's 240 watts. In this mode you would get 10 millivolts coming across here. So what you need to do is pass that into an analog input, read the 10 millivolts, and if you've got some kind of calibration on your input, you know what your reference voltage is, you can then read out the current that is being picked up by this. So that actually kind of works. So these are obviously big and bulky and quite painful. They're really only intended for use with a multimeter. Like normally what you would do is you wouldn't use this. What you would do is grab a multimeter. I don't have one handy right now. My other one is blue tacked to the bench. So what you would do is just put this into the multimeter, put it into a volts range, and then you would read millivolts off it. And if you had this in the 1 millivolt range, then for every millivolt you read, you're reading an amp. So it's basically just like a fancy probe for your multimeter. And that's why it's in this form factor. What you can do is walk up to like a switchboard or something, or a device you want to measure, you clamp this around it. But for permanent installations, this is obviously not very practical. It's physically very large, and also there are sensitivity issues with it. It's kind of a crude way of doing it. And there are other ways of measuring current. So this is another way of doing it. This is a Hall effect. This one, I don't know. This is, as I said, it's more than 10 years since I was doing this. So you can use a CT, which is a current transformer, or you can use a Hall effect sensor. And with this, what you do is, in a similar way, you pass the active wire through it, and the Hall effect sensor detects the magnetic field. And once again, you get an output on it. And in this particular case, this is a different board. It's got a different PCB in there. This is a board that was designed by my friend Sam Saby. Well, actually, it was designed by Luke Weston, another friend of mine, for Sam. because Sam had a business for a while called Smart Energy Groups, where he was doing energy monitoring, and similar process. You just plug this in. With this, what you need to do is disconnect or cut the active lead to pass it through the sensor. You can't just clamp it on like that, which means this is more of a permanent installation sort of solution. This is the sort of thing that you would put inside a switchboard. You could put one of these on every power circuit, and then this has got 6 input channels, and you could then read 6 individual power circuits. And the accuracy on these is a bit better, the resolution's a bit better, and they're physically very small. So you can imagine in a switchboard where you've got a few circuits side by side, it's not very practical to have one of these clamped over every circuit, but you can have one of these wired in, and it's quite neat and unobtrusive. So that's inductive, same as the clamp. Scott said, yes, cool. Yeah, I couldn't remember. There is a different type, which is a Hall effect one. It looks a little bit different. So the story about the shopping center. Okay, so the company that we were doing the contracting for, that was doing the data collection, what we ended up doing was sending one of these devices up to a shopping center in Brisbane because they were having some problems. Well, they were having excessive power use, and their bill was really high, and they couldn't figure out why. Now, as I said, this is more than 10 years ago, so my memory of the numbers is probably way off. And what happened was, the way the air conditioning systems work, or the HVAC systems work in large facilities like shopping centers, is because the volume or the mass of air is so big, it's not really economically viable to use refrigeration type cooling to cool down the entire volume of the shopping center. It would take a huge amount of power. So they do a few tricks to try to reduce their power consumption. And this particular shopping center, it was reasonably new. It hadn't been running all that long, but their power bills were higher than they should have been. Now, trying to figure out why. And one of these units got sent up to Brisbane, and they clipped it onto the on power leads of a couple of the systems that were running the air conditioning, trying to figure out what was going on. And the way the system worked is they had large baffles in the air conditioning system that could direct air into different places. So what they could do is draw air from the interior of the shopping center, run it through the air conditioning system, so like past the heat exchangers, and then bring the cold air back into the shopping center. So that's like a closed system where they're looping it around. They could also direct air in other ways. For example, they could dump air from the internal, dump internal air and push it outside. They could take external air and pull it inside, and either through the chiller. Yeah. So what this system was set up to do was look at the external air temperature, the internal air temperature, and the humidity and different other things. And what it could do is take, in the very early morning, so while the shopping center is closed, if it had been a hot day and there had been a steep temperature gradient where the temperature had fallen, so the internal air temperature of the shopping center was high, they could dump that air out and then bring cool air in order to start the day with a cooler air load without having to use the energy to then bring that temperature down. And what they discovered was that during this period of the early morning, it was like 3 a.m. or onwards, or whatever the time was, there should have been very low load on the system, because it should have just been the baffles in the right position and then fans that are pulling the air from outside and dumping it inside the shopping center. And instead they found that there was a really big spike in the power on their air conditioning system, and it didn't make any sense. They were scratching their heads and watched the cycle for a couple of days, trying to figure out what was going on. And in the end, they found out that what was happening was the air was being dumped in the wrong direction, and the chillers were running when they shouldn't have been. So effectively what they were doing was running the air conditioning in reverse, and they were trying to cool down the air that they were dumping out of the shopping centre and then evacuating cold air to the outside. So basically they were trying to cool down the outside of Brisbane by chilling the external air. Some stupid thing like that. And because of the energy that was involved, it was costing them a lot of money. You can imagine what your heating and cooling bill is at home for a house. Now think of the size of a shopping centre and how much power is used. That was, yeah, they were combating global warming. Yeah, by using more energy. Unfortunately, all the energy has to go somewhere. As I said, I might have the details wrong on that, but it was the effect of that was like millions of dollars a year on their power bill because they were trying to cool down Brisbane with a reverse air conditioner. Okay, so it was a little exercise. It took a few days and some monitoring, and they figured it out and fixed the problem and then saved themselves a whole lot of money. So that was definitely something worth doing. Now, the other way of measuring power, which is something that I've done, it's something that you see in low power circuits. So let me open a thing in here. Where is, I'm going to open up the LibraSat power supply module because I think I did it in here. Do I want to open that? Yes. Wow, it's been a long time since I've opened this design. And I will switch over to looking at Eagle. So let's have a look at the schematic first. When was this modified? 2013. Yeah, my memory is going to be kind of hazy on this one. So what I've been talking about so far is measuring power for AC, so like typical household power supply. That's where you use either a CT or a Hall effect sensor or something like that. The other situation is where you need to measure power at a much lower level typically, and it's DC. And that's usually done using something like a voltage drop across a very low value resistor. So where is that in here? So, oh yeah, just backing up a little bit. Where are we? I think it's in here. PV out. No. Fuel battery gauge. There, I think it is in there. I'll find it eventually. Just what I'll do though is back off and look at this board. So this is the this is a power supply board for a satellite, but it's an experimental one that's just used for when you have some kind of a test set up on the ground or running a high altitude balloon flight or something like that. And what it does is use a LiPo cell, and it's got a switch mode, it's got two switch mode voltage regulators for 3.3 and 5 volts. It's got interlocks for deployment, so there's a remove before flight switch. You've probably seen those red tags that are used on aircraft and different things. So what you do is have a safety interlock plugged into the device, which physically disconnects the power from it, and if that red tag is in, then you know it's safe. And the very last thing you do before it is launched is you pull out the red tag and it removes a safety interlock. So the RBF is satellite, and when it's sitting inside its deployment device, the switch is depressed, and then when it's deployed, the switch is released and it powers up the satellite. And the reason for that is that you do not want the satellite to be using any power while its solar panels have not been deployed, and more importantly, while it is within the launch vehicle, or in the case of RGSat, within the International Space Station, because we don't want the transmitters firing up or doing anything like that. So there are these two mechanical interlocks that are used to prevent it powering up. I'm getting a little bit off track here, but this is kind of cool. There is a USB port on here, which you can use for either charging or for communicating with the controller. And there is a DC jack over here. And what I was looking for, the point of all of this, was the current monitoring. So, oh yeah, there's a temperature sensor. I think there are top and bottom temperature sensors. Actually, I know a better one to look at. Instead of the power supply module, let's look at the payload processor module, which is this one. And this is I'll just turn on a couple of extra layers here. So this is the board that went into RGSat that ran all of the experiments while it was in orbit. And just down here we go, this is where it is measuring the current. So that thing there is a resistor, but it's a low value resistor. I can't remember what it is. It's probably like 1/10 of an ohm or something. Yeah, okay, so 0.1 ohm 2010 resistor. So the way this works is you pass power through a very low value resistor, but it needs to be very accurate, and measure the voltage drop across it. Now somewhere in here we'll be able, oh there it is, 5-volt current sensor. Okay, so in this case I was using a MAX 4372 current sensor chip, and what you can see right here is the 1/10 of an ohm resistor. So we've got 5 volts that comes in from somewhere, either the RGSat bus or the system, and we have 5-volt source. So there are multiple ways that power can come into this. And then the power passes through the 1/10 of an ohm resistor, and then it goes on to the main power bus right here. So effectively what happens is that as power is passing through this resistor, there's going to be a voltage drop, because it's the classic V equals IR. So all we need to do is use Ohm's law to measure, or to figure out what the current is through it, because we know the resistance is 0.1 of an ohm, and we can measure the voltage drop across it, and that then gives us the current. So this current sensor IC is measuring the voltage differential across this resistor, and then it is giving an output which we can measure and use that to detect how much current is being used. So if you're working on a project where you need to measure current within the system, and you can see here I've got a 5-volt rail current sensor and a 3.3-volt rail current sensor, that is another way to do it. So that's probably about all I have to talk about in terms of power monitoring at the moment. So apart from that, where am I? I'll get back to the front. Here we are. Okay, so now that I've given you time to all put a bunch of stuff into the chat, let's see if there is anything to respond to. Someone from Indiana, USA. Allsop69. Hey. John is in Perth. We've got people all over. That is cool. Oh, Jake said, hello everybody from Italy. I'm not sure if I pronounced your name correctly, sorry. Okay. Scrolling down. Yeah, okay. Oh, yes, Stuart said, hi, I'm from the UK. You mentioned some time back you developed an RGB version of the light switch with onboard ESP control. I'd be interested to hear more on these. Yes. I've actually been working on that over the last few days. I thought I might have one right here, but it's probably still in the lounge room because I spend every evening when I'm not on the computer here, on the computer in the lounge room. Yeah, it's not here. But because of all the interest in the light switch controller project, and I've got those PCBs, they're currently with DHL transiting from all PCB back to me right now. That's for the centralized light switch controller that I showed on the last live stream. And that will be able to interface with either the very simple switches that I've been using up until now, or the RGB version, which has an ESP8266 on it and can change the color on the buttons and do other things. So it adds extra functionality, but it still works with the same central controller. And because of the interest in that, it's also revived my interest in the RGB light switches. So I've been messing around with the software for that over the last few days. But I don't have one right here, so maybe I'll talk about that next time. And in fact, hopefully by the next live stream, I will physically have the light switch controller hardware here, the next version of it at least, and we can do more of a show and tell sort of thing rather than just talking about it. Oh, that's a good point. John Ford said, can't clamp over live and neutral because they cancel each other out. Yes. So if you are using something like this, then you can't just get a mains power lead and clamp over the whole thing because you'll get 0. In fact, I'm going to unclip my microphone here. Luckily I remembered that and I didn't walk away and rip the computer off the bench. What you're about to see may make your eyes bleed. So, if you are of a sensitive disposition, look away now, because this is truly disgusting. Alright, this is, as you can see, it's got spray paint on it and everything. The dodgiest power board in the world. And it's been cut. You can see that the active lead here has been cut and there's a joiner in there. And then the CT has been passed over the lead, so it's only over the active and it's not over the neutral. If it goes over the whole thing, it doesn't work. You have to have it just over the active or over the neutral. But active is really the sensible thing to do. Alright, any other questions? Where is it? AC units. Fang Lord of Time said, this is why AC units should have built-in power logging. Yes. And I think the, I can't remember the details. I assume that they did have some kind of power logging, but of course this is AC units that are on an enormous industrial scale. It's not a little box. It's devices that are, like installations that are bigger than my house. So it's consisting of a whole lot of, it's not like it's sort of thing that you get delivered as a unit and you take the box off and you install it. It's an installation that is built up custom to suit the requirements using various modules and parts. So who knows what sort of monitoring they had set up on it. Okay. Light switch controller. Oh, okay. So Dodgy just asked, any updates on the light switch controller? Yes. In fact, let's see where the PCBs are right now. Doing a quick DHL tracking update. Oh, no, that's the wrong one. That one is the previous shipment. It says they're delivered. I'm not sure where they are right now, but they're somewhere in the air, possibly, unless they're sitting in Hong Kong, like my last shipment was. It sat in Hong Kong for 8 days. Okay, so Larry says, made my own air quality sensor. Awesome. Pictures are on your Discord in Share Project channel. D1 Mini BME 680 and is battery operated. Lasts about 69 days between charges. That's really cool. Thank you very much. I haven't looked in the Share Project channel for a little bit. I should check that out. But yeah, that's great. So you got the BME 680 on it as well, which is nice. That's what I've got in the Pro version. So this is very hacky looking because I screwed up. This is the second PCB revision and I still screwed it up. That was the first PCB revision, and just down the bottom that's the BME 680, and that's the second PCB revision, which also has a BME 680 down there, a couple of RGB LEDs, PMS 7003, and ESP32. It's got a Vroom 32 module on the back, and what it should have is a 240 by 240 color LCD on the front for drawing charts and other fun things. So that's probably going to be part 5 now of the air quality sensor series, because I have just about finished part 3 and that should be up for patrons today. I've got about 25 minutes of footage of explanations of the source code for the sketch, and that'll be public probably in another day or two. And then because that one ended up going on so long, I have decided to push back the content for, let me see, I'll find some screenshots for it. Yeah, I've decided to push back the section on how to do reporting out of the air quality sensor. Let's see what I can find. I've got a whole lot of visuals and things here that I created to go in it, and I'll switch back to the desktop. So, for example, this is one of the things that I did to go into the episode where I'm going to talk about what these numbers actually mean. This is showing the relative sizes of different types of particles, and the question about viruses, no, you can't generally detect viruses because they're too small. They're down in this sort of region. And the sensitivity range. So this diagram shows you the sorts of things that you can detect with the Plantower sensor. And where's another interesting one? So this one, if it will ever open. So this one is something that I will be using to explain some of the ways that air quality is reported. So the different numbers that are used to, the different scales that are used for the different types of measurements. So if you've got your PM 2.5 24-hour average in the 42 to 47 range, and the PM 10 is in the 67 to 75 range, then according to the UK Air Quality Index, you take the higher of the numbers and your index would be 6. So there are things like that that I'm going to be talking about, as well as how to take the values that are being reported by the software and decode the JSON and put it into charts and that sort of thing. But all of that sort of thing takes time to explain, so that is going to be pushed back to episode 4, or part 4, and then part 5 is going to be the Pro version, which has got the BME 680 on it and all of the other stuff. Oh, this is a good question. And Allstop69 said, I tried to ask a few times, but have you ever set up a rolling automatic backup from one Raspberry to a second backup in case of failure? Firstly, sorry if I've missed that question and not responded to you. I haven't been deliberately ignoring it. A rolling backup, no. I haven't done that on a Raspberry Pi. I have done it on other systems, but at the moment I don't on my home automation controller. What I do have is a script that takes a copy of the configuration directory for and the configuration for Node-RED and anything else that's relevant on the machine, and it runs every 24 hours and asyncs the configuration back to a different machine, my NAS basically, which is actually one of my desktop computers, but it does multi-purposes. I use it as a NAS as well. It's got, I think, 7 hard disks in it, and so I can restore from that backup, and what I can do is apply that config onto a duplicate running on a second Raspberry Pi, and then I can fail over. The failover process at the moment is manual, and the process of taking the configuration off one Pi and putting it on the other is also manual, because I'd have to take it from the backup and push it back down. I don't push the backup onto the second machine automatically. But that is a really good question, and it's something that I need to address in the future. Alright, Martin said, with AC power monitoring in Melbourne and smart meters, can't you monitor power over Zigbee? That is a very good point. And yes and no. What you can do is monitor the overall power. Typically what happens with that is, if you have a smart meter, that is a single entry point into the power system of the house. So the meter is kind of at the demarcation point between the power company and your own internal wiring. And everything from the inside of the meter is your responsibility, from the outside of the meter is the power company's responsibility. But everything has to go through the meter, which means you get one number, and that is the total power consumption for the house. So that is useful in itself, and what you can do in a limited way is you can get a little display that uses Zigbee, I think. Is it Zigbee? Where is the smart meter comment? I've missed it. Yeah, Zigbee. They do use Zigbee, don't they? So what you can do is get a little device that you stick on, in your kitchen or wherever, and it's got a chart on it and it shows you how much power you're using, but that will be the total number for the house. What I want is much more fine-grained. I want monitoring at least per power circuit, and ideally per device. I'd like to be able to measure everything. So the other thing is that those Zigbee devices tend to be a little bit hard to link into anything external. So you can go to your power company and say, I would like to pay for a device to stick in my kitchen, but then how do you get the data out of that device? And that is a whole other problem. You can look at the number on the screen, but can you pull it into your home automation system? Okay. Danny asked, Is there a way to use something like a son-off but still have the light switch work in tandem? Doesn't matter if light switch kills power to both the light and the son-off. Short answer is kind of. Now, this is in some ways a little limitation of a son-off, and maybe there is an equivalent to a son-off that does this, I don't know. Ideally what you would need is something like the equivalent of a two-way switch setup. So the way that works, if you have a long hallway, for example, and you want to switch at each end of the hallway, either switch can turn the light on or off. It doesn't matter which one you use. What they do is pass power in from one side into the common of one switch, and then you have the two switched outputs traveling the length of the hallway, going into the two switch contacts of the other end, and then you have the single common coming back out. And the result is that you can either make or break the circuit from either end. Now, the way to achieve that with a son-off would be to have it so that the output is not just switched on and off, but it's got a switched output, switching between two outputs. And that would only work if you had constant active available, which you could arrange. So the short answer is yes, you could do it, but what you would probably have to do is modify the son-off. The son-off and the Shelly and I think pretty much all of those sorts of things have a single pole double throw relay in them. It should, I believe. Maybe they only have single pole single throw. I don't have one handy to have a look. But what they do is they expose only a single switched output. If you could modify the circuit board, like you could cut a track with a Dremel and you could connect to the second output of the relay, like the normally closed output, then you could wire it up with an external switch in the same way as you would do a two-way switch, like a passage light system. And that would work. Then the son-off could fire and turn the light on or off, and then you could flick the switch and turn the light on or off. However, that will only... Oh yeah, that would work even if the son-off failed, because what would happen is the son-off would fail and the relay would end up in its normally closed position, and then the light switch would continue to work as normal. So yeah, you could do that. Let's see, more questions. Oh, looks like I have missed a whole lot because I am way back up in the scroll. So Renia says, I would like to know, what do you think of the Tesla battery system that's been installed in Australia, and do you think it's possible to do a similar DIY system for the SuperHouse? I would love to have something like a whole house battery system, and it's definitely possible to do something DIY. This was mentioned last week, and there were a couple of channels, of YouTube channels, that were mentioned. There is a DIY Powerwall. I will drop a couple of links in here if other people haven't done it already. There is Yehu Garcia's channel. There are a few of them actually, people that have built their own DIY power walls. It sounds like this is a topic that is... I'm just trying to find the other one. Oh, I don't know. Anyway, I won't get into that now. We talked about it last week. So, oh, there is something specific I want to get to in a moment, but I'll just quickly scan down these comments. Oh, Genomi asked, Genomini? I'm not sure how to pronounce that, sorry. What type of relays do you use in your switchboards? 12-volt Arduino controlled. There is a link to those somewhere. Let's see. On at least one of the tutorial pages, I've put information about that. They are DIN rail mounted. What can I find? No, there's no link on the light switch controller episode. Maybe on the architecture episode? Oh yes, here we go. I will paste in a couple of links. So these are the relays, and these are the DIN rail mounts. Yeah, cool. So, okay. Richard said, oh, hang on. I've got a bit ahead of myself. So many comments. Okay. Smart meter report via ZigBee. Martin's answered the question already. Sorry, I hadn't got to your answer. Yes, Corinna, that you did notice that. That was discussed on the Discord just before I went live, so I quickly changed it. Don't know if other people have noticed. It was done deliberately. All right. Okay, oh, there's a comment here saying, Post Office is working 2 to 3 days a week in Hong Kong since the beginning of the month due to the confinement. Yeah, okay, that's interesting. So that would partly explain some of the delays on regular post coming out via Hong Kong, all the usual stuff that we order via AliExpress using ePacket or whatever, that typically goes through Hong Kong Post. In the case of PCBs, I'm getting all of those shipments done using DHL, which have their own facilities, so the delay would be elsewhere. I still think it's lack of aircraft, even though people tell me that's not the thing. Ooh, Fanglord of Time said, I am personally trying to build my own OpenPNP machine, but I'm also trying to design a modular controller for it that might use RAMP's 1.4 board to control it at first. And that is cool. So Fanglord, if you make progress on that, please report back about that on the Discord. And of course there's also the OpenPNP Discord that you might know about, and the OpenPNP mailing list, which is a really good place. Yeah, a RAMPS 1.4 board should be fine. The main issues with controlling the pick and place machine is just that it needs more channels. If you compare it to like a 3D printer where you have X, Y, Z and an extruder, and then you need to control heating for the heated bed and for the hot end, you don't need as many drivers, like stepper drivers. But for a pick and place machine, you very rapidly use up all the available channels. I've got 1, 2, 3, 4, 5. Yeah, I've got 5 stepper motors. And most pick and place machines, most DIY pick and place machines have 6 stepper motors on them that need to be controlled independently, plus vacuum control and other things. So that's the major issue. Just make sure you get a board that, think about all the things you need to control and make sure you have enough channels for it. Oh, Pete said, I bet he did it to block a logo. Yes, my own logo. Oh, Ecognito3 said, pity, MQTT, time series, data collection and processing, etc. is probably the bit I'm most interested in. So that's in relation to my comment earlier about the reporting being pushed back another episode. Yeah, sorry about that, but I really wanted to make the explanation of the source code a standalone episode because I kind of have the feeling that that is the one that people aren't going to care about. And I don't want to have a 50-minute episode that is 25 minutes of source code explanation and 25 minutes of how to set up the reporting and everything else, and then make people try to find the part they're interested in. So it'll come. Okay, so Richard said, any update on the assistive technology project? I spent the previous 7 years working in assistive technology, so I have an interest. Oh, that's awesome. Richard, I would love to hear the sorts of things that you've worked on. I am a total noob in this space. I certainly haven't spent 7 years working on it. I'm coming at this from the point of view of someone that has a background in hardware and software and building systems, but how it largely came about was because of the needs of my friends Nick and Chris and building systems that would specifically help them with whatever they happen to need. So I'm not at all an expert. I'm just someone that's trying to figure things out as I go. And in terms of updates on the assistive technology project, we have many. We've got a whole list of them. There is, I won't go into that right now. There is a lot. But we've got that classic situation where we've been working on a whole lot of things in parallel and got them to the point where they can be used by Chris to some extent. Things like the hand heater, the chair breakout, the Fly Sky CAN bus interface so he can fly an aircraft kind of works, and for driving remote control cars and things. The nurse call system using the load cell has been working. He's been using that, but then it failed because a couple of soldered connections. We'd basically built a dodgy prototype and he was using it, and a soldered joint failed on a lead. And that is the sort of thing that can have really, really bad consequences if, depending on the circumstances in which it happens, because things like nurse call systems can be rather life and death situations. And that's why you shouldn't mess around with that sort of thing unless you know what you're doing. And I don't know what I'm doing. I'm making it up as I go. But that illustrates the sort of situation we're in. What we've got is a whole lot of these projects that are kind of 80% there, and they are usable to some extent by Chris, but for other people to be using them, that it's like you get to the 80% mark and then you find that you've got to do the other 80% of the work in order to make it more generally usable. So what we've just been talking about is how can we take these projects that are mostly there and they are usable for him as a one-off and make them more generally available in a way that's going to be safe and will solve other problems that other people have. So it would be really cool to have other people involved in that. Matt Richards asked a very good question. For the concentration units, what's the difference between standard and environmental? This is for the air quality sensor project. This is a question that it broke my mind at first. I couldn't figure this out. The thing is that there are different terms used and it can be really super confusing and nobody explains anything anywhere. And that is partly what I want to help explain in the reporting section. So there are, when you get numbers coming out of the Plantower particulate matter sensors, there are three numbers that you get. One is what's called the SP, or the standard particle number. One is the AE, for the atmospheric environment number, and the other one is, what do they call it? PPD, that's right, which is particles per deciliter. So the first two are actually technically the same thing, but they're used for different purposes. So standard particles and atmospheric environment are both giving you a reading which is micrograms per cubic meter in that size range. The difference is that the SP, and the thing is that I actually haven't found any documentation on this anywhere. What I'm telling you now is what I've figured out by reading source code, by looking at data sheets and just trying to infer, reading between the lines. I haven't actually had anyone explain this to me in these specific terms, so I could be wrong. But my understanding is the SP number, the standard particle number, is micrograms per cubic meter when you are putting particles of a known size through the sensor for calibration purposes. And this is done for factory calibration. So what you can do is put the sensor inside a test chamber, and then the test procedure, as I understand it, is to use styrene beads of a very accurately known size and accurately known concentration. So into the test chamber you put these styrene beads, and then you read the value that comes back from the sensor. And because you know the concentration of the beads you put in, you can then calibrate the sensor. And the SP, so the standard particle reading, is a value that is tuned specifically for those calibration particles, and that then allows you to get your your adjustment factors or whatever for the sensor. Then the AE, which is the atmospheric environment number, is the value that you use when you're taking readings from just normal air. And technically they are both giving you micrograms per cubic meter, but one is specifically set up for calibration and the other is for general readings. I think that's the case. If someone knows better, please say so. And the other reading, PPD, is particles per deciliter. So that is a count, not a mass. So just a count of how many particles in that size range per deciliter of air. Alright, so sync your config to, oh, okay. Kevin said, have you tried the projects on Node-RED that can sync your config to a private GitHub repo? I hadn't even heard of that. That's a cool idea. I should do that. Thanks for the tip. Peter O'Sullivan said, can you use SDR to read smart meters? There have been attempts to read the Zigbee messages. So SDR, for people that don't know, is software-defined radio. That is that's a way of moving decoding of radio signals from the hardware realm into the software realm. I mean, this is a big topic to get into, and once again, I'm not really an expert on it. But the way typical radios work is they have a tuned circuit at the front end. So you have an antenna, and then the signal comes down the antenna, and the antenna itself will be picking up everything, depending on things like the characteristics of the antenna, the wavelength. It will be more sensitive to certain frequencies and certain polarizations, but essentially you have, at the end of the antenna, you'll have just everything. That signal then has to go into a tuned circuit which will reject anything that's outside of specific frequency range. So you'll have like a bandpass filter, and anything that's below a certain frequency it will cut off. Anything above a certain frequency it will cut off, and it will leave you with the signal which is just the frequency you care about, and you can amplify that and do a whole lot of stuff in hardware. So the end result is that what you get coming out is a signal which is just the signal that you want, and everything else is rejected. So that's the traditional way of doing radio reception. With SDR, so software-defined radio, what you do is ignore all of that filtering in hardware. You take the radio signal that comes in, amplify it, and then you have a raw signal, which is basically like a garble of everything all overlaid on top of each other, and you feed that into a computer so that the signal ends up in the software realm. And then instead of doing the things like the frequency filtering in hardware, you do it in software. And it gives you a lot of flexibility, because it means that you can essentially build a radio in software instead of having to change hardware to change its characteristics. So it's really handy if you want to take a signal you may not necessarily know about and tune it and adjust to process it in the way that you want to. Anyway, that's kind of off topic here. So the question really is, can you intercept the signal from a smart meter and read it using your own device? Short answer is, I don't know. In theory, you should not be able to unless you have the key to decrypt the signal, because there is encryption on the connection. So what you need to do is get the key, and your power company should be able to give you the key for that. But that's a whole can of worms that I don't know very much about. So I could be giving you wrong information there. And this whole episode today is just me making stuff up and telling you the wrong thing. Gabrielle says, greetings from Argentina. Hey, that's cool. And Renee from Berlin, Germany. That's so cool. Speaking of Berlin, I just watched the show Unorthodox on Netflix a few days ago. I watched all the episodes straight through because it ended up being such a cool show, which I think was filmed in Berlin and is largely set in Berlin as well, partly set in New York, but almost all of the filming was done in Berlin. And I don't know if it was just the locations that they chose for the filming, but Berlin looks like an incredibly green city. It looked really pretty. I've never been to Berlin, but I would love to visit one day. I went to Munich last year, and that was cool. Oh yeah, and Dodgy said, couldn't you just put a monitoring lead on each relay? Yeah, on each relay in your subboards. Exactly. That is exactly the plan. That wherever it is, I had these things. My whole plan was to put one of these on every single relay so that I could measure power individually on every device in the house. So because all of the switching in my house is centralized in the switchboard, it's not, I've got everything wired back to the switchboard and then dozens of relays that control every light individually. That's ideal from a monitoring point of view because I got one centralized place. I don't have to put a monitoring system at each end node because I can measure the power right at the switchboard where it goes out to the end nodes. So, yes. Matt said, I used in-rail mounted energy meters with Modbus interfaces that give me a bunch of useful metrics, one on each circuit. Yeah, that's cool. That's the industrial approach to doing it, doing it properly. Okay. I am so far behind on these comments now. I'm going to have to skim down through this or I'm just never going to catch up. Aaron asked if I've tried the new Dita smart switches. No idea how long they've been out, but found one in Bunnings yesterday and got Tasmoda on it. I haven't. I've got a Dita smart power board down here, which I pulled apart to do a video about putting Tasmoda on that, but I haven't got back to that. I've actually filmed a fair bit of that video, but it needs a fair bit more work. What I've heard though is that there are two different types of the Dita devices. So Dita is a brand that is in like the big box hardware retail stores here in Australia, and they make smart plugs that are similar to the Sonoff and light switches. But I've heard that there are two different types, and some of them have ESP8266 in them because they've got a 2-year module in them. Some of them have something else. I can't remember what. They might have a Broadcom chipset or something in them, and of course Tasmota won't run on that chip. It'll only run on the versions with an ESP8266. So yeah, well, if it runs on those smart switches, that's cool. But for anyone else that's thinking of doing that, before you rush off and think that all Dita products are supported by Tasmota, just check first. Make sure you get one that does have the ESP8266 in it. Or if you want to take your luck and try it and let us know, that would be cool. Okay. Oh, Jason Perry asked, is HB Powerwall an Australian channel? Yes, I think it is. That is... Where is HB Powerwall? Yeah, I was I was watching his channel just a few days ago. He's got a video about how to do the heat shrinking on 18650 cells. So, in fact, I will drop this channel in to the chat for people that are interested in DIY power walls. That's a good one to watch. Now, let's see. Connection denied. Block country. Interesting. So there's something going on. So Zhao and Antonio have both said connection denied by geolocation setting. What are you trying to connect to? Is that to the forum or is that to something else? I'm not sure what's going on there. Okay, so there's a question from Repairs for Life for everyone. Hi mate, do you have a good coding learning software that you would recommend? I don't know. That's a kind of a bit of a general question. I don't know. Please contact your administrator. Lots of people saying connection denied by geolocation settings. I'm going to scroll to the end and see what that is in relation to. Put myself back into full screen, please. Really? Am I more interesting than a schematic? I don't think so. But if you insist. So, where... I want to figure out this geolocation problem. What is it that people are trying to connect to and getting... okay, so this is different. This is a different issue, it's not the geolocation. Allstop69 said, I'm there but everything is blanked, do I need to be accepted? I assume that's in relation to the Discord. If you have just joined the Discord and you want to see and interact with everything, what you have to do is go up near the top, the list of topics. There is a thing called rules. So you go to the rules channel and then you have to give it a thumbs up at the bottom of the one post in the rules channel, and that's just how you access the basically you get approval. So then you should be able to see everything. That'll solve that problem. Oh, okay, so the geolocation, that's interesting. So site I posted with AU domain. That site I posted was the Altronics site with the information about the relays and the DIN rail mounts. I had no idea that that was blocked outside of Australia. That's really weird. Looks like Altronics, being a local Australian retailer, are deliberately preventing other people from accessing it. After this live stream, what I'm going to do is I'll fire up a VPN to one of my machines in the US and try connecting back to Altronics and figure out what's going on with that. But I don't think I can solve that right now, because everybody would be just sitting there watching me silently staring at a screen and typing. Okay. So yeah, I need to find a good place to put references for things like okay. What I need to find is a good place to put links to stuff that questions that come up regularly, like what relays do you use? I get that question a lot, and I usually just direct people to Altronics. But if they are now blocking non-Australian sites, that is non-Australian users, that's no good. I've got to find a better place to direct people to. And kind of on that subject, I've just been in the process of putting together a page that lists some of the gear that I use. And I'll stick it in here. And part of the reason for that is that I do get people asking me regularly, what microscope do you use, or what's your soldering iron, or those sorts of questions. And every time I would have to look up the information and figure out where to send them. So what I've done is started creating this page where I'm just compiling a list of things and links to them. This page is for gear in the workshop. But I also need to have a resource page similar to this that will do things like list the relays, the DIN rail mounts, and all of the other useful things. Now, I'm kind of ignoring a whole bunch of chat for now because I really want to get to this point that I've been wanting to mention right from the start. But first I've got to find a particular URL. So here we go. Copy link. All right, so oh, sorry about that. That was probably very loud. So a little while ago, okay, mentally backtracking, I'm resetting myself here. When I restarted doing these live streams a few weeks ago, part of the reason that I wanted to do this was to get more two-way interaction. I didn't want to just be doing videos and then having them go out and then maybe get some comments, and that's pretty much it. I wanted to be able to interact with people more. And also, I wanted to be able to find out more about the sorts of things that other people are working on and how their workshops are set up, and the sorts of things that you are doing. And so a few weeks ago, I started recording a lab tour. I actually began recording this before the whole COVID-19 thing and the lockdown happened, and then I put that aside because I was working on the air quality sensor project. And I'm going to get back to it, and that's also partly what prompted me to start that page, because the page of gear is going to go with the episode about lab setup. And I've got a whole lot of principles that I use in terms of how things are organized, and I'm going to talk about that in the video. The reason I'm bringing all of this up now, even though that video is not ready, is that the Guru of Nothing has just posted a video which is a tour of his own lab, which is really cool. So this, which hopefully everybody can see without any geolocation blocking, is, I'm just going to put a note in here. So Guru is one of the admins of the Discord and the forum, and the start of this video is a little bit embarrassing because he talks about SuperHouse a bit, but once you get past that and he starts showing you the setup in his own lab, that's really cool. So you should go and check that out. And what I would love to see are more lab tours, because I want to see how people are getting themselves set up and how they're working. A whole lot of people are displaced right now. Even people that traditionally work in electronics or software development, and they go to work and they have access to good facilities, suddenly don't have access to those facilities, so they're having to work from home. I've seen a whole lot of people posting about this, like Chris Gamble, for example, posted on Twitter during the week some photos of the lab setup that he's got at home. And normally he works in a co-working space, I think, which is set up with all of his gear, but now he can't go there. So his home lab is something that he's been putting together just over the last week or two so that he can get some stuff done. So a whole lot of people are now in the process of having to put a whole lot of time in at home instead of in their normal workplace, which means that a whole lot of home labs are being set up, or they're being taken from an occasional hobby use sort of environment to, oh no, now I have to be working in this 8-10 hours a day, 5 or 6 days a week sort of situation. And so I suspect that a whole lot of home labs are going to get a whole lot more well equipped over this period. So I want to see your home labs. That's the challenge. Please make videos, or even just take photos and post in the Discord or in the forum. That would be really cool. All right, now scrolling back. Oh, Mike said he's got to run. Okay, see you, Mike. Thanks for coming along. Okay, so the hookup. Hey, Rob. Thanks for coming along. Said, do the homebrew PNP machines do computer vision stuff like orientation of larger chips? Yes, they do. My pick and place machine has 2 cameras on it. There is a down-looking camera and an up-looking camera, and it uses an OpenCV pipeline to be able to fix orientation. And it's not just of larger chips. You can do it with like 0603s, 0402s. And I need to do a video about my pick and place machine. Unfortunately, it's... Oh, actually, see that blue thing right there? That is the back edge of the corner of the feeders, of the end of the feeders, and then this that you can see hanging down here, that's the bare end of the cover tape feeding, coming down off a couple of reels. And what it does is use the downward looking camera, which is attached to the pick and place head, to do things like find fiducials on the PCB, so that when the job starts, it finds the fiducials and gets their coordinates, and then figures out the offset of that compared to where the fiducials should be, and then it can apply that to all of the part positions. So what I can do is put a PCB down and have it in approximately the right place. It doesn't have to be super accurately placed, and the machine figures it out. It finds a fiducial as it goes, oh, that's where the board is. I've now got accurate positions, and it can also use that for doing things like setting. You can use the downward looking camera for doing things like finding the pickup position on the feeders, and it uses it for finding the holes in the tapes on the fixed position strips. So it uses the offset from the hole to find the part. And the upward looking camera, which is in a fixed position, is used for correcting the position of the part on the nozzle, because I'm doing lots of hand waving. It'd be so much better if I could actually show you. Oh well, a different time. I need to get a roving camera set up so I can just move it around the lab as I talk about things. What happens is that the tape has little rectangular slots in it, or a slot that is just larger than the part, but the part can still move within the slot, and also the position when the nozzle picks up the part may not be totally accurate. So if you pick up, say, an 0603 resistor, the pickup may not be dead centered on the part, or the part may be slightly rotated in the tape. So what can happen is that if you pick up a part off center and then you rotate the head 90 degrees, the rotation will spin the part so that it is, it's all offset. So what happens is that it can move the head over the fixed position camera. It then does an OpenCV pipeline where it takes a picture of the part looking straight up at it, and it does edge detection, removes all of the background, so you end up with just a rectangle that represents the position of the part, and it then figures out the offset of the part on the head, so that then when it's rotating and moving it into the right place, it can move it however many fractions of a millimeter it needs to in order to put it down where it actually needs to be. So you can pick up a part off center, move it, and put it down on a PCB that is in a non-specific location and get it accurate to a fraction of a millimeter, which is really cool. Alrighty. Richard, this is getting back to assistive technology. Richard said, my experience is that assistive technology is 80% generic. The remaining 20% is bespoke because each special needs individual has different needs. We try not to force the individual to adapt to the technology. Yes, that is a really important point in a couple of different ways, both from a practical point of view, because different people have different physical needs, and also from a psychological point of view, because what one person thinks is important is not what someone else thinks is important, and that could be because of different circumstances, different personalities, or whatever. So the one thing that I've had hammered into me, even before I was working with Nick and Chris, I've heard this so many times from people that work in accessibility in the software realm, is don't assume that you know what someone else needs. You have to work with the end user, not dictate to the end user. So work with the end user of whatever your system is, listen to them, and then provide what they need or what is going to solve their problem, which may not be the problem that you think they have. And everybody's different. So yeah, that's a really critical point. Thanks, Richard. Okay, Toby Robb said, one way to read meters is to read the blinking watt-hour light into an LDR. Yes, I actually have that on my switchboard right now. I'm not using an LDR, I'm using an SE something 6000. It's the light sensor. I will find this quickly. What I'm using is a light sensor module, which has, it's a TEMT 6000, and it's it kind of works like an LDR in that it gives you an output based on light intensity, but it responds much faster than an LDR. LDRs tend to be a little bit slow. So what I've got right now is actually power over Ethernet going out into my switchboard with an Ether it's got an Ether 10 out there, and it's connected to one of these light sensor modules. And the light sensor module is in a tiny little plastic container with a hole in it, and then silicon, so it's all nicely isolated. And then that is attached with double-sided tape over the flashing LED in the on the power meter. So I can't remember what the calibration is, but like for every, I think it might be for like every 1/10 of a kilowatt hour or something, it blinks once. So you count the blinks, and then you can see how much power is being used. The frequency of the blinks shows your current rate of consumption, and counting the blinks gives you your total energy usage. Each watt hour. Yeah, Toby said some power meters have an IR send and receiving coupling, and sometimes the IR out pulses with each watt hour. Yep, exactly. So you can either measure the IR. So this isn't a situation where the power meter is specifically designed to have some external device connect to it, and it uses the IR coupling. But they also have typically a visual LED. So if you look at your power meter, when power is being used in your house, you'll see that there is an LED that blinks occasionally, and as more power is being used, it blinks more quickly. So you can either monitor the IR if your meter uses that, or you can monitor the visible light LED if it uses that. Renier said, how many items in the SuperHouse can you control via the implant that you showed to enter the garage? Right now, that's the only thing. So that door there is the main entry into my lab area. That has a Lockwood Nexion lock on it, which has been modified so that it can be controlled using MQTT messages. And I can scan the RFID implant and then have myself authenticated and unlock the door. But right now, that's the only thing I use it for. All right, Geo was the issue. Okay, so scrolling down, trying to catch up again. Electronics link. So Aaron asked, are you aware of the Neos Smart Cam? I believe it's the same as the Wise Cam. Wondering how this can be flashed with open source firmware for local recordings without subscriptions. I have no idea. Sorry, I don't have a Neos Smart Cam, and I don't know anything about how they work. In fact, the person on this chat who probably knows the most about cameras right now is Rob from the Hookup, and I don't remember specifically a Neos Smart Cam. He did a video fairly recently about video doorbells. So that's, if you are watching this right now, you're interested in home automation and you don't know about the Hookup, definitely go and check out the Hookup on YouTube. In fact, I will find the URL for his channel so that I can make it super easy for you, because Rob does really good videos about things like reviews of security cameras and all sorts of stuff. The Hookup, here we go. So go and check this out. So I believe Rob is a science teacher, I think. And so he talks about all sorts of interesting home automation devices. Okay, so still talking about the Ultronics links. Dodgy said I could access it and I have my VPN turned off. Oh, I couldn't access it and I have my VPN turned off. And Dodgy, Dodgy is in Australia, so I don't know what's going on with Ultronics. I'm going to try to figure that one out. All right. James Kennewell said, what does a PNP machine cost doing it yourself? Mine so far has cost probably around $2,000 Australian, but it's been reasonably incremental. I did a talk about it at a conference a few years ago, and I included a breakdown of all of the costs. I actually had a bill of materials for everything that I had in my machine at the time and what it cost me. And at the time, it was around about $1,000, I think, give or take. But there's a whole series of things that you can add on to make the machine better. So if you think about the cost of building, say, a 3D printer, it's like a DIY 3D printer, you can do something very similar in that sort of price range. The major difference is that you need it to be physically quite a bit larger. So mine is 600 by 600 millimeters for the frame, and there are some extra things that you need that you don't need on a 3D printer, like a vacuum pump and vacuum solenoids. You need more channels on the controller and various other things. So it's not exactly the same, but if you have looked at a 3D printer and thought, I could build one of those, then you could probably also build a pick and place machine. There are slightly different problems to solve, and things like adding vision to it. You can build a pick and place machine with no active feeders, just with static feeders by taping strips down, which is what I did. I had only static feeders for the first couple of years I was using it. You can skip the vision system, you can skip a whole lot of stuff, and you can build one for a reasonably low price. But then as you start adding more things to it, like auto feeders, which are a lifesaver. What you'll find is that you go through parts surprisingly fast. And when you start laying out strips of parts and putting them down, you might put out 50 or 70 at a time in a strip, this long. There's about 70 parts in standard 8mm tape at 8mm pitch. And so you will go through those parts in a jiffy, and then you'll be constantly peeling off tapes and putting more tapes down and then recalibrating the position of the tapes. It drives you nuts. So being able to put at least high volume parts like 1K resistors, 10K resistors, 100 nanofarad capacitors, the sort of stuff that you use all the time on every design, if you can have enough auto feeders to take care of those, and then use fixed position tapes for the slightly more unusual things, that's a really big step up. Okay, so, BitLooney, so that's another channel that you should check out. BitLooney's Lab. If people are interested in, lots of tech stuff, then BitLooney's Lab is a good channel to check out as well. And BitLooney has recently set up his own pick and place machine. He's assembled a light placer kit, I think. I haven't actually watched that video. BitLooney's Lab is this one. So, yeah, I think BitLooney might be wanting, I don't remember what software he's running on it, whether he's using OpenPNP or if he's using the Light Placer software. Oh, Scott just said, being the invite link to the Discord. Is there a problem with the invite link? I don't know about that. If there is, please let me know. Trady Trev. Hey Trady. Said nothing beats the accuracy of the meter billing you. Yeah, that's the number that the power company is going to use when they send you a bill. So it does kind of matter. Oh, and Matt says, I use a pulse counter for gas. The meter I have has a handy RJ11 port on it, which has a couple of pins that are shorted once per rotation of a 1/100th of a unit. Yeah, that's fantastic. So in that case, the gas meter already has an interface on it. So what that's talking about is what's normally referred to as a dry contact interface. And that is when a device has something like a relay inside and it triggers the relay each time that it needs to send an output. In fact, that's how things like motion detectors work. Technically it's a dry contact output, and that's because it is simply a connection that short circuits, and you can detect that. It's not providing any electrical bias to the output. If you have an output, say you have a device that provides an output which has a ground connection and then a digital line, which might go between 5 volts and 0 volts or whatever. That's not a dry contact output because you need to do things like make sure you either use opto-isolation or have a common ground to the device that you're measuring. But a dry contact output where you just have an output which shorts together, like a relay output, that means that you can comfortably connect an external device into it, and then you can measure the connection across that to detect pulses, and you can be fully isolated from the device that you are reading. So something like a gas meter, which has an RJ11 port with a dry contact switched output, means you can just plug into it and then you can measure the pulses. That's really cool. So Matt, that is good to hear that is working for you. Oh yeah, Allsop69 said, I know this is more of a personal question, but how many videos do you have in the making on the list? And can you give us hints? Plug your ears, the hookup. I know there is no hate, but okay. What videos do I have in the pipeline? Now, in terms of the hookup, funny thing is that when I was doing the bulletproof Wi-Fi videos, I did bulletproof Wi-Fi for home automation part 1, and then I was working on part 2, which was about things like how to do VLANs and all of that sort of stuff. And I was in the process of recording that when Rob's video about Unify and VLANs came out, and I stopped working on mine at the time. But I will probably get back to it. I really want to do more of that bulletproof Wi-Fi series. I was going to do a series of 3, but I stopped because Rob ended up covering that topic pretty well. I've got some other ideas about things though that are a bit different to the way he's done it. So, what am I looking for? That's right, episodes, source files. If I bring this over here, you probably can't read this all that easily, but this is where I've got some footage already collected. So I've already got footage for the reporting version, for part 4 of the air quality sensor for reporting. For the Pro version, I've been doing a video about custom rack mounting. This one is really interesting. I've got I've got high hopes for this episode. I've been working on a project for a while, which is running. This is a follow-on from that whole Unify Wi-Fi series. It's DIY Wi-Fi access points with support for personal pre-shared keys. And what that is doing is getting around the problem of having devices that all connect to the same Wi-Fi network with the same password. And that's basically a stupid idea. That comes down to the way that the Wi-Fi protocols were designed right in the early days. And Wi-Fi conceptually was simply a radio link to a wired network. And typically on a wired network, once you're on the network, everything is trusted. There's no internal partitioning unless you run VLANs and that sort of thing. But Anyway, I'll end up talking too much about that episode. What I've done is I have designed my own wireless access points based on Raspberry Pi, and it runs software that allows you to define a different password for every client that connects to Wi-Fi without using PEEP. So you don't need to use enterprise authentication. The reason for that is that enterprise authentication is typically not supported in small IoT devices. And so what this does is gets you around the whole problem of getting, say, a light globe, like a smart bulb, and having to give it your one and only Wi-Fi password, and every device has the same password. With this system, you can build a Wi-Fi network, which is for your IoT devices, and give every device its own password, even though they're all on the same SSID. Because the other way of getting around this that is a really nasty hack that some people do is broadcast a whole heap of SSIDs, and then you can associate a different password with each SSID, and you create one for every device. And that's horrible. Another one, this one, I started filming this one a while ago, and I nearly electrocuted myself while I was doing it. This is the IoT of electric blankets. This was hacking an electric blanket using an ESP32 so that it could start automatically and monitor its temperature and everything. Happy Bubbles Bluetooth presence detection. So this is a video that I started filming quite a long time ago, and then Happy Bubbles went out of business, so I stopped. These are the devices that I showed on the live stream last time, which used fixed locations, fixed receivers, to talk to mobile beacons so that you can get the location of people within a house and detect someone's phone or a BLE beacon or whatever. I'll probably get back to that, even though Happy Bubbles technically is out of business now, so the devices that I was using you can't buy anymore, but it was all released as open source. You can build your own, and you can do it in other ways. You don't have to use the Happy Bubbles hardware. In fact, that might end up being rolled into the DIY Wi-Fi access point hardware, because we can do BLE through the Raspberry Pi and use the same access points for both location sensing within the house and for running the Wi-Fi network for all IoT devices. This episode is HomeSense. This is, in fact, I've got one of them here. This has become kind of redundant now, but this is a project that I worked on. I've done a few different versions of this. It is an ESP8266 based environmental sensor, and my webcam is horrible quality, so it looks really blurry, but it's got a little switch mode voltage regulator on there, and you can see, whoop, everything's backwards. Just on there you can see a sensor on the PCB. Has got a really weird shape. That is to provide thermal isolation to the sensor, and it can do environmental monitoring and reporting. I've done a few different versions of that with different sensors. So switching back to the desktop. Oh yeah, Lab Tour 2020 is that one, so I've already done a fair bit of filming on that. NTP analog clock. This is a project to take a wall clock from the kitchen and use a tiny Pico, which is made by Sion the Unexpected Maker, who I think might be in the chat, I'm not sure. So what I've done is I've got a tiny Pico in the back of the clock, and what it does is connect to Wi-Fi, connect to an NTP server, get the current time, and then generate pulses which advance the hands of the clock. So it's an analog clock that sits on the wall, but it's synchronized to NTP, which means it can do things like change with daylight savings time. And it's always spot on. Yeah, and I've been doing that with a tiny Pico, which I'll probably talk about a whole lot more in future videos. That is one of Sion's many projects. So Unexpected Maker, you can see in the chat down there. Check out, while I'm putting channels into Unexpected Maker, I'm doing like a a big channel promo episode today. So here it comes, Unexpected Maker, his YouTube channel, and one of his projects is the Tiny Pico, which is a very small ESP32 development board. I won't go into that in particular right now, even though I'm tempted to, because I'm going to talk a whole lot about that on the NTP analog clock episode, because one of the reasons that I picked Sion's board for this is that he specifically designed it for low power use, and I don't want to have to run wires to the clock. I want to be able to run it off a battery, but we need Wi-Fi for NTP, and we need to sync it occasionally, so being able to put it into a very low power mode is important, and having minimal power usage. There are some interesting things about that in the Tiny Pico, so I am sure I will go into that in great detail at the time. Then I've got some footage from Rock Solid Wi-Fi Part 2 and Rock Solid Wi-Fi Part 3. Oh yeah, so Tuya, I've been recording some stuff about Tuya modules. Zigbee to MQTT. This is cool. In fact, let me see. I don't think I've ever talked about this one, but this little device here would help if I switched cameras again, wouldn't it? And I've just locked my own screen. Okay, so hopefully you can hear me now. Well, that is really interesting. So OBS died, and my computer locked itself. Hang on, I've got to switch a few things back here. OBS. But I relaunched OBS, started streaming again, and it's reconnected to the same stream. That's really cool. Hopefully there will just be a black bit in the stream. So, where I was about to show you this. This is another project that is going to be shown fairly soon. This came about after the Zigbee Sonoff episode. Around about that time. Just looking for a screwdriver right there. And what's going on inside here is that there is a Bluetooth. Hang on. I've got to disconnect myself in order to reach a hex driver. So what's going on here is that this is a Zigbee. Yeah, it's a Zigbee to Tasmota device, and I use this to receive messages from from various Zigbee devices around the house, and then pushes the messages to MQTT, and then I can pull it into Node-RED and do whatever I want with it. So I'm using environmental sensors and door sensors and all those sorts of things. Actually, I'm going to unplug it, which is going to kill my Zigbee to MQTT. And what you can see on here is there is a Zigbee module on here with this is a version with an amplifier on it, so it's quite sensitive. And then there is a Wemos D1 Mini, and it's all sitting on a little PCB that I designed. And what this does is receive Zigbee messages, and then they are processed by Zigbee to Tasmota running on the D1 Mini, which then pushes those messages to MQTT. And the guy who wrote Tasmota to, I keep getting it the wrong way around, Zigbee to Tasmota, has been using one of my boards. in France, and he's been using one of these. So currently, as far as I know, the only 2 people in the world using this are me and the developer of Zigbee to TAS motor, and that will be in a future video because it's kind of useful. All right, now where am I up to? Oh, that's right. I was showing you upcoming videos. So what I was showing you there, if we go back to the desktop view, so this directory is where I store footage that hasn't been used yet, and this is just videos where I've actually started filming something, or I have some content for it already, but it hasn't been finished yet. And there are many more that I want to do. I've got a whole spreadsheet listing different things that I want to do episodes about. Where are we up to? We're heading towards 2 hours. So it's just about time to stop anyway. What else is there in the chat? Oh yeah, Richard said, love the designs of the low power boards, Unexpected Maker's Tiny Pico and Kevin Darrow's Trig board. Yeah, it's that's really cool. Still framing? Okay. What else? Now I did have some things that I was wanting to cover today, and we're now at almost 2 hours. I've covered a couple of them. What do I have here that I was planning to talk about? We talked about, oh, okay. All right, one last thing. I actually got some stuff out in preparation for this, and I will switch back to Eagle because I thought that what I would do is, if I couldn't think of stuff to talk about, I would show a couple of Eagle projects, and I got out some basic things to talk about. And as it turns out, we've got to nearly 2 hours and I haven't got to them yet. Where is it? Case. Okay, so what I wanted to talk about very briefly, and this is quite simple, so it shouldn't take too long. I wanted to talk about PCB templates and things that you can use as a project template. Now, I'm going to look at a UB3. All right, so I've been doing this, as you can see from the copyright date on this, I've been doing this for a few years. What I have found is really useful when I'm designing projects is sometimes if you want to make something really small or optimized, it's good to design a 3D printed case like this, and you can make a case that exactly suits your requirements. But 3D printing doesn't scale particularly well, and the finish on it is not as good as proper injection molded stuff. So what I often do is design my projects around an enclosure, and that's what this template is for. What I can do is duplicate this Eagle project, and I've got a board which is optimized for a particular type of case. Now this one is optimized for what's called a UB3 project box, which is just like an injection molded box about that size, and it has guides in the side of it so that you can put a PCB into it and it clips into place if you make your PCB the exact right size. And it has screws in the corner to attach the lid, but the stakes for the screws protrude into the corner, and that's why it's got this funny shape. So what I've got in Eagle are a number of projects which are just templates similar to this that I can duplicate and then begin my new project in that, and I don't have to recreate the physical outline of the board. Now I know that it's going to be spot on. So let's see what we can find. I had something here. Oh yeah, Here is an example. I'll just change to a different outline. So this one is for a UB3 size case, which is fairly large. And then I've got another one here. This one is for a UB5 case, which is physically smaller. So looking at what's on the screen there, and then I will switch the view. Oh, look, where are we? Front. There we go. Okay, so this is a UB3 case. You know, typical small project box, and has a lid somewhere, probably back in the container I just grabbed this out of. And as you can see, actually I'll pop this out of it first so that you can see the case on its own and see what I'm talking about. So plastic project box, and it's got these stakes in the corners, and it's got these little mounting tabs on it. Now these boxes are reasonably cheap. Like, I can't remember the price, but you know, $2 or something. And smaller ones, which I'll show you in a second, might be 50 cents. So to make a project that you can reproduce in some quantity without going to the extent of doing a custom case, which costs thousands for the die or for the mold to be made for injection molding, this is a midway point between the sort of thing you do with 3D printing, which might be very low volume and custom, and in custom injection molding, which is high volume. It's cheap, but you've got to get over a really high threshold. Designing for an off-the-shelf case can give you a really good finish and, you know, nice surface, good quality, but at the low price. You just have to conform to the requirements of the case. So that particular, you can't see my screen, can you? If we go to that. So that particular screen of PCB outline is that way. You can see there that the shape of this PCB is based on that outline. So I used that particular template when I started working on this project. And the result of that is that this PCB can clip straight into this case. The only thing I need to do is cut a hole in the end for the power connector. Now, this particular project is something that I haven't shown in a video, but this is also one that will be in a future video. There are two versions of it. There is this one. This is a board that you can use to take any, it's basically a universal Wi-Fi interface for remote controls for devices. Like think about a garage door or something like that. What you can do is take the PCB out of your garage door remote control and cable tie it through the holes in the PCB so it's stuck in place on here. And then you can jumper across from the buttons on the remote control to contacts on here. And this board runs TAS motor. And then what you can do is use MQTT to pulse the buttons on the transmitter of the remote control. And then by clipping, it's got, you can see the ESP8266 module on the back there. So because it's designed to fit into this board, it should, if it all fits, it just clips down and snaps into place. And then the remote control transmitter is in the box there with it, and then you put the cover on and you have a nice little box that you just apply power, and now you have an MQTT enabled remote control for whatever device it is that you're wanting to hack around with. Now this particular one, this version just has MOSFETs, so it uses open collector outputs, and that's fine if you are running a common ground to whatever your target controller is. This version has read relays, so each of these is a dry contact output. You can wire that across the contacts of a button for a transmitter, and then when you fire the relay, it's as if you press the button on the transmitter. And both of these things fit into the same case. And that is the sort of project that I use these templates for. Now let's find another template. Oh yeah, this one. Switching back to the desktop. This particular one is for a case with a part number of VGS28, and I think these cases cost maybe 70 cents, quite cheap. It's a very small case. There's also a cover. Once again, I don't have the cover, it's in the box that I just grabbed this out of. But what's inside here, this is the HomeSense project that I just showed a few minutes ago, and it's that weird shaped PCB that fits into the case. Now what I did was start with this project, and you can see that it's got the holes for the screws to mount it in the case. There's a little self-tapping screw just up there. There are two of them. They go through this hole. So I started with this particular template, which is a generic template to fit into this enclosure, and then I modified the outline. Switching back to the main camera, I modified the outline to do the thermal isolation around the sensor and to pull the PCB back from underneath the Wi-Fi antenna. But it still started with that basic template. So that is basically it for the template stuff. I just wanted to share that that's kind of a useful technique if you are designing a circuit board. I think a lot of people that do circuit board design, coming at it from a hobby point of view, don't think about the enclosure that it's going to go into at the start of the project. And I know I don't a lot of the time. Most of the time what I'll do is think about, oh, I want to make a thing that does this, and then start a new project and put all the parts on it, and then oh, you end up with a board that's 47 millimeters by 63 millimeters, and then you start thinking, what case am I going to put this into? And often it ends up just with some mounting holes in the corner of a rectangular PCB, and then it gets screwed into an enclosure using standoffs, and it can end up being pretty ugly. But if you think ahead and start with an enclosure in mind, what you can do is make sure that your PCB conforms with the requirements of the enclosure, and you can get a much better result coming out. Alrighty. Oh, John Spencer, hey. So John just said thanks for the chat. Oh, and after talking for 2 hours, I need a drink. My throat is failing me. Okay. So, unfortunately, I don't think John Spencer has a YouTube channel I can point to, but he builds really cool things. And just a little while ago, he was working on a project to make a game console, you know, like a MAME arcade sort of thing, but he laser cut all of the parts out of transparent, is it acrylic? I'm not sure. So basically what he's done is built a transparent game console, and then it's got RGB LEDs and things all the way through it. So it's amazing. It's a work of art. John, you should get yourself a YouTube channel and start doing videos about that sort of stuff, because it's cool. Okay, so I'm going to wrap it up now, I think. But oh, the hookup. Rob said, wrap it in electrical tape and be done with it. I've done that before, more than once. No, the advanced version of that, you wrap in electrical tape and then you put heat shrink over the whole lot. Like, where is it? Oh, it's not here. I thought I had a Sonoff programming adapter here that I'd done exactly that too. It's here somewhere. Yes. Okay. Stephen Harrison, this is relevant to what I was just talking about, asked the question, any tips for drilling and milling the ends of the enclosures for connectors? That is really painful. And what I've done with this particular one is, because I wasn't making a lot of these, it was fairly low volume. What I did was make a template that fitted over the end. So I got a piece of cardboard with a bend in it and measured out the size and cut the rectangle out using a scalpel, so I got it fairly accurate. And what I did then was just put the template over the corner, use a pen, draw inside, and that gave me the mark. And then I drilled with a drill press and used a panel nibbler and cut it out. So that is really crude and it does not scale very well. The better way to do that is with CNC machining. What you could do is make a fixture. I've got a CNC machine over in the corner, that corner, which you will see in the lab tour video. And the more scalable way to do this, if I was doing more of these, is I would make some kind of a fixture that allows me to put the box down in a very repeatable place. So I would probably make something that has an L shape in it that this fits into, and that's where it registers against the corner. So you've got a known starting point every time, and then clamp it from the opposite corner and use a CNC machine to cut the hole out of it. The setup involved in doing that was more than the time involved in just manually cutting some of these holes. So if I was doing a bunch of them, I would CNC them. I thought about lasering them. In fact, there was a project that I was doing with Chris not long ago where we used his laser cutter. He's got a much better laser cutter than mine, and it's got adjustable Z height. Mine is a really cheap, crappy Red Sail K40 laser, which doesn't have a motorized Z height. So to adjust the vertical focus is a pain. You've got to do it by turning the little focus thing. And Chris's has adjustable Z height. So what we did was get some enclosures and we put them into the laser cutter, and we set the focal point to be the top edge of the case. And then we put a piece of metal on the inside, so that what happened was that because in a laser cutter, ideally the laser should be perfectly columnar. It should be just straight, but the reality is it's not. What happens is that the laser that comes out of the laser tube has a width to it. It then goes into a lens, and the lens focuses it down to a particular point, which is where the cut takes place. And so if you have material which has thickness to it, the edges of the cut are not perfectly parallel. They will be slightly angled. And the idea is to get the focal point right where you want the cut to happen. But what you can do is take advantage of that and have it not cut through the bottom of the enclosure. And we did this, and it actually kind of worked. It left some marks on the inside, but it worked. So what we did was set it so the focus was on the top, and the laser cuts the hole in the top part. It then passes through, but by that point a lot of the energy is already spent because it's been melting the top part of the case, and it's also got past the focal point and the laser has started to spread out again. So by the time it hits the bottom part of the case, the laser has spread, the energy is being dissipated, and it's not too bad. So you can cut this sort of thing in a laser cutter as well, which is much quicker setup than a CNC machine. But be very careful of the material that you're cutting, because if you cut, you can release chlorine gas and all sorts of really nasty things depending on what material it is that you're cutting. I'm just trying to think about what it was that we cut. I actually can't remember what it was we were doing that for. It was a few months ago now. Okay. Okay, I'm going to wrap it up now. I could keep going, but it's already been well over 2 hours. I need to rest my voice. And thank you all very much for coming. And also, I feel not so bad about cutting it off because we're going to do it all again next week anyway. So, thank you for coming. I will look through a couple more of the chat messages and maybe answer them directly, but I'm going to cut it off now before I keep going, because I'm going to keep seeing comments and I'm going to keep responding to them, and this will never end. So thank you. I hope you have a fantastic Sunday, and it's really cool to have live chat going on with this stuff. And I would really like to get a portable camera that I can use for these live streams. So it's not just the fixed cameras in my computer, because then I could take you for a walk around and show you the pick and place machine and the CNC and everything else around the office. But at the moment, the camera that I use for recording video, normally I can't use for live streaming. It just records to an SD card, and I don't really have a way of capturing it live, using it as a camera. Maybe a webcam on a long USB cable will do. So that can be for a future thing. Once again, thank you, and I will see you all soon. Make sure you jump on the Discord or the forum and come and say hello. Bye.